Okay, in this case, let me show you what we've got, and what I said earlier will start to make a little more sense. First of all, I'm picking case 1 here. The slow step, or the rate determining step, RDS, is the first step. And that's this. So what you see below this red line here are the elementary steps. So these two reactions are called elementary steps. Okay? The first one's slow. That's the rate determining step. The second one's fast. You'll see listed over the arrows K. Those are rate constants. Remember, the larger the rate constant, the faster the reaction. The slower the rate constant, the smaller it is, the slower. What's on top is the overall reaction. Now you'll notice that the sum of the elementary steps will equal the overall reaction. Can you see that? Mm-hmm. Take a look at that. So what is an intermediate here? NO3 appears here, but not in the overall reaction. So we call that an intermediate. Okay? So you're always going to see intermediates around in various places. Now, again, this is the easiest case where the first step is the rate determining step. Remember, the rate determining step is what determines the overall speed of the reaction. It is the slow one, the dopey one. It slows the team down. So the rate of the overall reaction is always dependent on the slow step. So in our case here, the rate of this reaction is equal to the rate of the slow step. K1, because it's reaction 1, K1, times NO2, and what's the exponent?
1.
Squared, because there's 2 of them. It's 2 NO2 basically. Goes to NO3 and NO. Done. That's my answer. That's the rate. So this is the easiest possible case. I have now solved for the rate law for this set of reactions when the first one's the rate determining step. Whenever that happens, that is the easiest possible case. You just write down the rate law for the first reaction, and you're done. Any questions so far? Yeah?
Why did you take NO2 for the concentration?
Why did I pick NO2 for the concentration? Because when I write rate laws, I always write it for reactants. And since the reactants are NO2 and NO2, 2 of them, I'm writing that concentration. If I wrote the rate for the second reaction, it would be NO3 concentration times the CO concentration times K2. But I don't need that because that's the fast step, so I can ignore the fast step. Is that cool? Okay, any other questions? Yeah?
Will it be given what's slower and which one's faster?
Is it given what's slower and what's faster? In this problem, in this case, yes. So for case 1 and 2, the rate determining step is given, and it'll say either it's the slow step or it'll say it's the rate determining step. When we get to the third possible case of problems, it might not be given. And that's the hardest possible case.